So welcome to this course E203 on analog integrated circuits, and all the circuits they will be implemented using transistors which are called CMOS. So this is introductory class on this course, and in this lecture we will see uh, in detail the meaning of each of the words in the title of this course, and then we will take one example from our real life to understand what are the various modules. That means what will be various classes or families of circuits that we will cover or study in this course. So as you can see, there are four words in the title of this course: circuits, integrated, analog, and CMOS. So fundamentally, the most important word is circuits, and these integrated, analog, and CMOS, they are qualifying. That means they are telling more about the circuits. So we'll see that what are circuits, and then what are integrated circuits, and then why analog, and then what is the meaning of CMOS, and what are other possibilities. So first word is circuit. So in electronics, we use components called resistors, inductors, capacitors, diodes, and transistors. So these are the components or elements that will be used to form what is called circuit. So what is circuit? Circuit is interconnection of some of these elements or components with at least one loop, that means one closed path. And this interconnection of all these elements or some of these elements, that is called network. So circuit fundamentally is a network of these components with one or more loop, or that means closed path. Okay. So this is the, you can say, the sort of formal definition of circuit. So we will have to interconnect these, and of course this interconnection is done with the help of a conductor, which we'll be calling as wire or interconnect. And the nature of interconnect, the nature of network, and the nature of elements decide what the circuit can do. So now the second word is integrated. So if you talk about circuit, then the circuit can be implemented in real life, that means fabricated in real life, in two different ways. So based on the implementation or fabrication, the circuit gets divided into two major classes. First is discrete circuits, and second is integrated circuits. So this is, keep in mind, from a fabrication point of view. From theory point of view, both the circuits, they are analyzed or explained or studied using same theories. There is a slight difference in the discrete and integrated circuits. If the frequency of the signal is very high, otherwise there is hardly any difference in terms of the theory of these two circuits. So only in terms of fabrication there is a distinction. And as the title suggests, we will be talking about these because most of the circuits that we encounter in real life, they are of this family. So now, what are discrete circuits and what are integrated, and which one is, of course, better and which one dominates and why? So if you talk about the discrete circuit, then as was pointed out, all the circuits, they will be basically network of individual components. So in the discrete circuit, each the component of the circuit, they have their own physical separate existence. So the components are initially physically separate, and then they are typically manually interconnected using wires, and they are what is called solder. They can be solder or interconnected automatically using machines also, but that is not the key point. Key point here is that they are physically separate and their size is large. You can see them with your naked eye very easily. You can hold them, and because they are large and they are physically separate and then they are interconnected using wires, so these discrete circuits, they are also large. Their size will be typically of order of few centimeters by few centimeters. And here, of course, you can interconnect only a small number of components to form a circuit. So you can say disadvantage is that they are large and small number of components can be interconnected, and because they are connected manually and with the wire, so they are very vulnerable. They usually break down easily, so they are unreliable. So these are the disadvantages of this circuit, but of course these are easier to fabricate, and initially all the circuits, they were of this type. But these days we encounter circuits which are called integrated circuits, and here, unlike the discrete circuits, the components are initially not separate. You will not be able to see them with your naked eye. And how this fabrication starts, that on a piece of semiconductor, typically silicon, we fabricate all the components: resistors, diodes, transistors, capacitors, even inductors also. But of course, the inductors will be made from conductive elements. But other components like resistor, diode, and transistor, they can be fabricated by modifying the semiconductor, for example, silicon. So here all these elements, they are going to be very small, of order less than micrometer. These days almost going up to the order of nanometers also. And then they will also of course be connected using conductors. They are called interconnects. And this, because they are very small, so you can have a very large number of components. So large number of components are possible, and because they will be what is called packaged, that means covered with strong material, typically that black color plastic that you might have seen with many circuits. So they are very rugged and quite reliable also. So these are the advantages. This very small size actually leads to these two things. And one more advantage that arises out of this small size of each of the components and the overall circuit size also. The circuit size uh, will be typically of order of few millimeter at the max. Typically it is less than a millimeter by millimeter. So, and because they are very small, so you can have very large number of components. So this implies more functionality. That means a single circuit can do various other jobs. Not only that, for given any small area, you can have circuit which will be more capable than the corresponding discrete circuits. And this property that they are small in size and leads to large number of components on a given piece of semiconductor, that is called typically wafer or chip, uh, has revolutionized electronic industry. And this idea of fabricating all the components on a piece of a semiconductor and then interconnecting them to realize integrated circuit is so important that the person who proposed this idea and successfully demonstrated was awarded Nobel Physics Prize in 2000. And the person who was awarded this prize is named Jack Kilby. He, along with another person, Robert Noyce, who later on founded Intel, was awarded Physics Nobel Prize. So from this, you can guess that this simple idea of integration uh, is so important. So as I pointed out, in terms of theory, there is going to be no difference in integrated and discrete circuits. But we have titled our course in terms of integrated circuits. Now coming to third word, that is analog. So a circuit, if we represent using this black box, will basically take a voltage or current as what is called input, and then it will produce again a voltage or current on some other location which will be called as output. So we will be providing what is called signal, and then it will be doing some operation or doing some processing of this input signal, and it will produce a signal which we will be calling as output signal. And by signal, we mean that time varying voltage or current. So each circuit, they take time varying voltage or current and they produce time varying voltage or current typically. So with respect to this signal or the time varying voltage and current that they are taking, the circuit gets divided into two families. Analog circuit and digital circuits. So as I pointed out, the circuit will sense or take a signal which will be typically time varying voltage. That means x-axis is time and say y-axis is volts. So typically signal will be something like this. So here we see that this signal has a lower value here and a maximum value here over this range. So this is lower value of the voltage, this is higher value of the voltage. So within this range of lower to higher, you will notice that the signal always takes certain value in this range. All the values in this range will definitely be taken up or assumed by the signal at least once in its duration. So we see that we say that the signal is continuous over this range, and all such signals, they are called analog. So this signal will be called as analog. So any circuit which takes analog signal, that means signal which has continuous value between two range, and it also produces a similar type of signal, analog signal on the output, will be called as analog signal. While another possibility is that we have again a time varying voltage, but it has this kind of variation. Here. So here we can see that the lowest value is here and the maximum value is here, VL, VH, but over this range, the signal has value either this lower one or this one or this one and this 0 of course and then this. That means signal never takes value over these small ranges. You will never find a time when signal has these values. So you can see that signal is discontinuous over this range, unlike analog which was continuous. So if we have this kind of signal, so these signals, they are called digital. Even this digital also now gets divided into two major categories. One is binary. That means the signal will have only two values. For example, this lower value or this higher value. And it will never assume any value over in these two extreme values. So if it has only two values, then we have a binary digital, and in our life we actually encounter this kind of signals only. Very rarely we encounter signal where we have more than two labels, and these will be multi-level digital signals. So most of the electronic circuits, they are binary digital. So in short, we simply say digital. So if we have a circuit which senses digital signal and it also produces digital signal on the output side. Then we have digital circuits. And these days, most of the digital signals, circuits, they are digital in nature. And reason is that these signals, they can tolerate what is called noise. That means suppose you have this digital signal and then uh, noise gets added to these like this. So instead of having smooth high value, it has a fluctuating value, which of course fluctuates over a small range. Then in that scenario also, it is found that these digital circuits, they will not respond to these small fluctuation in the values of the voltages. So they will still treat this time varying value as say VH or VL. So what is called is noise immunity exists in the digital circuits. So this is one main advantage of digital circuits. Second is that using digital circuits, we can implement few numbers of very simple mathematical operations, and those operations then can be used to implement any complicated functionality. So these two regions, immunity to noise and ease of implementing any given functionality, is main reason why digital circuits have become more popular. And when it is implemented, it leads to another advantage, that they tend to consume less power compared with their analog counterpart. So predominantly, predominantly, most of the circuits in today's world, they are digital. So one natural question will arise, that if digital circuits are so popular and so versatile, then why we are still studying analog? Why everything hasn't been converted into digital? So for that, we will take up one real life example. So that will justify that why analog should exist, and then that will also lead to what are the circuits that we will study in this course, and what are the various modules, that means families of circuits. So the example that we will take is that of an audio system. So this audio system basically captures our voice and then reproduces it. For example, what is happening here right now, my voice is being captured by microphone at this end, then it is getting what is called digitized and then transmitted, and then at your end, speaker is finally converting the signal, that means voltage that it is receiving, into audio, that is mechanical energy. So if we see the audio system at block level, that means what are the major components in terms of black box, then it will look something like this, that at the uh, first end, where for example at my end there is a microphone. So this microphone, what it is doing is, it is sensing voice, which is mechanical energy, and producing a time varying voltage. This voltage is going to be very weak. So what we will have to do is, first we will have to enlarge it and then do some of the filtering. And then we have another block. And then at this end, either this can be stored on say DVD or memory, or it could be transmitted. So here we can have DVD if we want to store, or then it could be say wire for transmitting, that means sending. So here the voltage that is produced by microphone after sensing voice is going to be continuous. That means it will vary continuously over two voltages, VL and VH. So signal that is produced because of real life phenomena, for example sound, is always going to be analog. So there has to be a system which will sense it and so-called process it, that means modify it as per our need. So since this voltage is going to be of order of millivolt or sometime even microvolt, so it of course has to be uh, amplified. So here we have amplifier. So this amplifier will increase the amplitude of this, and then it will be given to another block which is called filter. So here the signal what I have shown here is in what is called time domain. That means x-axis is time and y is voltage. But if this signal is represented with the help of Fourier analysis in terms of sinusoidal, then we will see that there will be various frequency components in this signal. So in terms of what is called frequencies or in frequency domain, this will look something like this. So this will be confined from 2 kilohertz up to 20 kilohertz. So the y-axis again can be power or voltage. So we sometimes want to eliminate some of the unwanted signal, because this microphone will not only pick my voice, but it will pick other voice also, other signals. So filtering is required. That means removing some of the frequency components. That means slightly altering this signal, but yet preserving its message that it is carrying. And because we will be ultimately storing it on say DVD or memory or transmitting, so this has to be converted into digital. That means in terms of two voltages, low and high voltages only, and typically they are symbolically denoted as 0 or 1. So there is a circuit. What it does is it senses analog signal on the input side, and then it produces uh, digital signal on the output side. So it changes analog to digital signal. And this circuit will always take another signal which is called clock. And this clock is basically going to be a digital signal, a periodic digital signal between two values, which could be between 0 and some high value, or 0 and 1 symbolically. So it will be always a square waveform with certain frequency, and this is called clock. So clock will drive, or ADC takes clock as one of the input signals in addition to the signal which it processes. So this is the story on the input side, that on my side. On your side, story will be that system will start from here. This is what your system is getting, or audio player will have this thing, and then it will have to drive the signal in reverse direction. So it will start from, say, DVD or memory, and because it is in digital form, so it has to be converted actually back into analog form. So there is a DAC, and then there could be again filter, then amplifier, and then finally speaker. So now you can see the signal travels in this direction, and so this digital signal has to be converted into analog form, because our voice is analog. So what we should get here should also be analog. That means the signal that should be fed to speaker also has to be analog. So this digital information or the voice in digital form that has been received or stored has to be converted back into analog form, and then there could be filtering, uh, sometime done for certain sound effect. So again we will have a circuit called filter, and then we have amplifier so that we can control the volume of the sound or voice that is produced by the speaker. And this block DAC, this also will take clock as one of the inputs. So here you can see that the ultimate goal of any circuit, whether amplifier, filter, ADC, uh, is to process the signal which are created in real life or physical world. And if you observe the signals which are produced in physical world, whether the voice signal or whether the image signal, so they will always be of continuous nature. Even the ECG signal, biomedical signal that are sensed for medical diagnosis, they will always be continuous. So there will always be system, maybe a small number of system in the beginning to handle the analog signals produced in the real life. Right. So we will always have analog, and ultimately when it is reproduced for our use, that time also again it has to be analog. So when the signal is picked from the real life and processed, and finally it is produced for use in the real life, at the both the end it has to be analog. So that is why analog systems will always exist, and in between there will be digital system. And the reason I have already pointed out, that they will be more tolerant for the unwanted fluctuation that occurs in the signal, uh, which are called noise, and versatility, more capability of processing. That means they can do various types of mathematical operation or manipulation on the signal that are being produced in the real life. So because of these reasons, there will always be digital, and because signals are always analog in nature, produced in real life, so there will always be analog. But most of the circuitry, they are going to be of digital nature. So this is to convey that there has to be analog, and there will be digital also. But now this gives you idea of what are the families of circuits that we will be studying in this course. So first circuit that we find in this audio system is amplifier. Second circuit is filter. And these two circuits, they are analog, because here you can see that their input and output both are analog. Similarly for filter also analog and analog. But for these circuits which has analog signal on one side, digital signal on other side, they are called mixed signal circuits, and they are also called data converter, because on this side what we get is typically called as data, and this also can be called as analog data. So they are data converters, to be more specific, but in a general sense they are mixed signal circuits. So we will be of course not studying these mixed signal circuits and the circuits that come after this, because they are going to be purely digital. So our domain is going to be up to here, 1 and 2. And of course here you can see that we require a circuit which should produce periodic signal. In this case, this signal is square in nature, but there are many other examples, especially in communication system, where also we need a source of periodic signal, but that signal need not be square. It can be sinusoidal also. So we will be also studying this circuit, the source of periodic signal, but we will confine ourselves to cases where the signal are going to be sinusoid. By the way, if you have a large sinusoid signal, that will also, for most of the practical purpose, will behave like a square waveform. The circuit will treat it as square waveform. So these three elements we will be studying. And on the receiver side, on the other side of this system, also you can see that we again have a power amplifier, we have filter, and we have source of periodic signal. So these three are going to be the three families or three sets of circuit that we will study in this course. So these are going to be three major modules. But now we will see that there are going to be sub modules also. For example, amplifier. Here you can see that the amplifier, they have been used at two locations. On the receiver side, immediately after the microphone, which is also called transducer because it converts mechanical energy into electrical energy. And then on the receiver side, immediately before the speaker. Speaker is also transducer. So both are analog, both are amplifier, but there is a slight different condition prevailing for the amplifier in the receiver side. That means immediately before the uh, speaker. So here what will happen is, you can see that the voltage that it will be handling are going to be very small. They will be typically of microvolt or millivolt. And on the output side also, the voltages are going to be small, very rarely less than more than 1 volt. But on this side, because we will be typically requiring large volume for the voice that speaker produces, so here there has to be large voltage to be more accurate, more power. And there could be few more amplifiers before this last one. I have shown only one, but there could be chain of amplifiers, that is called cascade of amplifiers. So the voltage that it will be handling and the current or in terms of power also are going to be large. So uh, these amplifiers, they are called power amplifiers. So the amplifier that we will study will be of two natures. One is, one amplifier handles small voltage, so that is why it will be called as small signal amplifier, and this will be on the transmitter side immediately after microphone, and then there will be amplifier which will handle large signal or large power. So they are called power amplifiers. And both the amplifiers, they will be handling signals up to 20 kilohertz. So they are small frequency amplifiers. But we will be hardly talking about this because most of the frequency that we will discuss are going to be small. So distinction is only in terms of the power or voltage that they handle. So these are the two different modules for this course. Now these small signal amplifiers, they themselves will be implemented or realized in various ways. So there will be various circuits for this small signal amplifier. For example, there will be amplifier which will contain only single transistor. So there will be single transistor or single stage amplifier, and then there will be multiple transistor or multiple stage amplifiers. So this amplifier module is going to be the biggest module in this course, and this itself will be divided in two major parts: small signal amplifier and power amplifier. And the small signal amplifier again will get divided into these two major categories. So this amplifier, so these are the various modules that we will study. And in this amplifier, we apply certain additional theories, what is called feedback theory, to achieve certain desired functionality, which we will talk in detail in a later part of the course when we start. So there are certain techniques which are applied in amplifier, not only for single stage, but also for multiple stage. So the another module that we are going to study is feedback amplifier. And then, as I pointed out, this voice signal in frequency domain will have various frequency components. So what ultimately we want from this amplifier is that it should increase each of the frequency component by same factor. Scaling up should be independent of the frequency of the signal present in this voice signal. But unfortunately, that does not happen. So in real life, it is found that any given amplifier will be amplifying certain frequency components better than the other. So it becomes important to know that given any amplifier circuit, what is its frequency response? That means how it amplification changes with frequency. So another module that we will be studying is frequency response of amplifiers. So this major module itself will have all these sub-components. You can say 1.1, 1.2, and then we will move on to other modules before returning back for 1.3 and 1.4. So amplifier itself will have 4 sub-modules. Now the second major circuit in the audio system was filter. So this is going to be second major module for this course, And filter, as we know, basically stops certain content, certain thing which is fed to the filter circuit. So this filter actually stops certain frequency components from reaching on the output side. So to be more precise, this is frequency filter. And all the circuits, all the useful circuits, they invariably have filters, because the signal that comes from real life invariably contains many unwanted signals also. So that is going to be a second module. And third, uh, circuit, they will be producing periodic signal on the output side, and such circuits, they are called oscillators. So this is the third major circuit that we will study in this course. And for our case, these periodic signals, they are going to be sinusoidal, but many of those circuits can be easily modified for uh, square or periodic signal also. And in fact, one of the circuit that we will see will produce triangular periodic waveform also. So these are going to be three major modules, and first module itself will have four sub modules. So these we will study in this course. And the last word of the title, which I could not explain, that is CMOS. So this was the fourth word of the title. And CMOS actually stands as acronym for CMOS fit. So this is complementary metal oxide semiconductor field effect transistor. So this is also fundamentally transistor. For example, BJT is another transistor, and here you can see that we have what is called field effect transistor. So functionality is slightly different from that of the BJT, but here also holes and electrons are basically involved, and theory is explained in terms of those two elements. But key distinction between CMOS, or in short FIT, and BJT is that BJT actually uses both electron and hole at the same time for its functionality. But FET, they use either only hole or only electron. So there are two versions of this device. One will use only electron, so they are called NMOS in short, and another device will use only holes for conduction, and they are called PMOS. So in fact, we will study these two devices in a little bit detail, because we will be making or studying all the circuits using only this type of transistor. Uh, so N stands for electron, P for hole. So they come in two versions, this MOSFET. They come in two versions, NMOS and PMOS. And PMOS is complementary, that means dual of NMOS. So any functionality can be implemented using either NMOS or PMOS. So these two together, they are called complementary MOS. And all the digital circuits, they are fabricated using both they use both NMOS and PMOS simultaneously, and that is why those circuits they are also called CMOS in short. And the fabrication technique is called CMOS technology. And the same technology, that means the same foundry or factory where this is fabricated, digital circuits are fabricated, can also be used for fabricating analog circuits. So if the analog circuits, they are fabricated using MOS, NMOS or PMOS, they are called MOS analog circuits, or in more common terminology, CMOS analog circuits. But unlike digital circuits, analog CMOS analog circuit need not always have both NMOS and PMOS, which happens with the digital circuits. So all the circuits, as I pointed out, will be based on uh, CMOS transistors, and that is why we have CMOS analog integrated circuits, name of this course.